Right now, the world is in an age where technology is deeply involved in our daily lives. That is the reason why this research is focused primarily on the energy usage of smartphones, because of its increasing demand by the general world population. Of all the electronic devices, the ones that stand out the most are smartphones, because they allow us to be connected a great part of the time. However, they need an electric current to function. It is known that energy produced from non-renewable resources are highly polluting our environment. Taking into consideration this, we have the responsibility to try to conserve energy and make the most of it as possible and sustainable. The identified problem to study is the waste of electric energy on smartphones. In order to reduce the waste of battery life on smartphones, it was decided that the objectives of this research would be to study how three factors affect the battery life of smartphones and to prove if there is a linear relationship between the factors and the battery life. With this research, it is hoped to obtain results that help to propose a way to reduce the waste of power, and also it is hoped to obtain an approximation of how it is mobile engineering community behaves in terms of daily battery life consumption. The studied process was the discharge of smartphone batteries. Here shown the input process output diagram to analyze and understand better the process. And these are the noise factors, and the design factors. The hypothesis to be tested was that by eliminating two applications, the performance of the battery can be increased by 50%. The proposed sampling method was a random simple one, and the information was gathered using an internet survey. The design matrix is composed by three factors, three levels, and a response variable. The chosen factors are number of applications, usage hours, and brightness level, and the levels are iOS, Android, and Windows. Lastly, battery duration is a response variable. The results of the multiple linear regression, the ANOVA, and the factorial design will be analyzed. First, a straight-line multiple regression was made. In the linear model, three equations were obtained, each for a single operating system. By analyzing the determination coefficient, it can be concluded that the model does not feed the data properly. Neither it is going to be good at predicting a new value, nor fitting the next value to be found. The only factor that does not have a linear relationship with the battery duration is the brightness level. That is why there is no multiple linear relationship between the input variables and the response variable. For the factorial design, it is deduced that the number of applications has no effect on the battery duration. The other factors were discarded by Minitab due to the number of unusual observations and the correlation. It is recommended to do a deeper experiment to obtain a larger sample that represents the population and that the data have a normal distribution to perform a better analysis. It is also important to change the method of data collection, perhaps doing face-to-face interviews to ensure or increase the veracity of the data.
Created using Powtoon.